Oh, you didn't take it. Thank you for going out.
Yeah, but I moved over and did the put point, blah, blah.
All right. This I'm going to cut out of the tape so I can say this now freely. First of all, if you like what I did this semester, first of all, before I even do that, there's something even more important I need to discuss with all of you. I might have mentioned this a long time ago, but I think now is the time to mention it again, and that is, listen carefully. I never, ever judge anybody by score they get on my test or grade they get in my class. It has nothing to do with who you are and what type of person you are. True story, years ago at the other school, I had a student taking my organic Chem 170, she flunked it. A couple of semesters later, took it again, she flunked it. And a couple of semesters later, she took it for the third time, and I'm thinking, oh, please, I hope she does better. And she got an A. And after the class, she came to me and said, I think I should just tell you what happened. I said, you don't have to. First time I took your class, I had major health problems, and I just couldn't study. Second time I took your class, I had major family problems, and I couldn't really study. And luckily this time I could study, and I stayed healthy, and so I never, ever judge a person by a grade in my class or a test score on a test. And I'd like to thank each and every one of you for being in my class. It's been a pleasure and an honor getting to know you and teaching you a little about my world of chemistry. All right, now, after saying that, if you like what I did this semester, go to ratemyprofessor.com and put something nice down. If you didn't like what I did, you can go to ratemyprofessor.com and put something not nice. All right, now if you really like what I did, last night I posted the following. If you go to Blackboard, you'll see there's now in contents a folder that says important email addresses. If you click on this, you'll see the president's COD and the board of trustees. And if you really, really, really like what I did this semester, send them together at the same time an email letting them know how well I did. If you didn't really, really like what I did this semester, send them an email letting them how badly I did. But either way, send it to them, and there's their email addresses if you want. The only advice I'd give you, if you're going to write to them, write it, let it sit for a couple hours, and then reread it and see if it still looks good. And by the way, address Dr. Caputo as Dr. Caputo, not Mr. All right, what I'll be doing today and Wednesday, I'll be going through the test reviews, but at the same time, more on Wednesday. I've got time today too. I'll put some important problems on here, so take good notes. I'll have this on Fridays, Friday's video I'll take, and this will help you. I've done it all the classes. All right, first of all, I started out the 4 branches of chemistry, and those are organic, physical, analytical, and the most important one is organic. You should know that. Everything you see on the slide here is on Blackboard. All right, next. We talked about matter, and I don't think I have a definition on the final. By the way, did I go through last Friday the final point breakdown yet? Did I do that? So I better stop and do that. It's in Blackboard, and I should have gotten an email. The final will be 1 hour. The way I structured this course, I'm making it so you should succeed. Hopefully everybody does. Instead of having it 2 hours, it's only 1 hour. Be similar, a little longer, to the hourly exams. The point breakdown, test number 1 will have 16 points. Test number 2, 44. Test number 3, 29. Test number 4, 21. If you notice, it adds up to 110. So there's 10 bonus points. And that should help you. The best way to study for it is go through the reviews and use your hourly exams as practice problems. If you can do what's on the hourly exam, you should do well on this. It's similar to an hourly exam. Remember, next week is finals week, so we will not have class on Monday. It's finals week. We will have the final in here at 9 o'clock on Wednesday. And you'll have 2 hours, but you won't need it. If you didn't need 2 hours for my hourly exam, you won't need it for this either. Well, maybe you will, but you'll have it. Another thing I should mention real quick, if you look at my syllabus, due to federal laws in my syllabus, I do not discuss grades via email or phone. So please don't ask me, why did I get this grade by email or whatever. I shall tell you this, anybody within 10 points of the cutoff, I automatically go back and regrade their final to make sure I haven't made any mistakes. Over the years I've done it. The most I've ever found on a final mistake was 1 or 2 points. And usually that didn't help a person get to the higher grade. But I still do that because I want to be fair to you. All right, any questions about the final? There'll be similar problems like you see on the hourly exams or the practice problems. Will be the same problems? No. Will be similar? Well, look at the practice problems. Weren't they similar to the hourly exams? All right, let's get back to this. All right, important thing you should know. Remember we did, let's do it one more time. Class participation time. Class, what are the 3 states of matter? The first one is, everyone.
Solid.
Thank you. Next one.
Liquid.
Oh, come on, fire up. One more.
Gas.
Yeah, thank you. I'm not going to do that. You guys are burned out. All right, anyways, you should know. A solid has definite shape, definite volume. Liquid, indefinite shape, definite volume. And a gas, indefinite shape, indefinite volume. Talked about types of matter, pure substances and mixtures. When we talk about properties of matter, there's physical properties and chemical properties. Physical property is something you observe that when you do look at it, it tells you something about it, like what color is my shirt, what color is my hair, what I still have left, things like that. A chemical property tells you how something interacts or changes, such as the water in my water bottle will not burn, but gasoline is quite flammable and will. Believe me, you don't have to try it at home. And then we talk about changes in matter, physical change when it changes from one state to another. An example of that, water freezing, water boiling. It's going from one state of matter to another. Chemical change is when something goes from one type of matter to a different type of matter. Example, and as you learned this semester, I'm a pyromaniac at heart. And if you take a piece of paper and burn it, or a candle, the wax changes to something else. Same thing with the gasoline in your car. Temperature, you learned all semester, degrees Fahrenheit, degrees Celsius, degrees, or Kelvin. And here are the formulas I have posted online. if you look at Blackboard, important information, I think it's about 2.5 pages. These formulas will be given to you. Now, why don't I have as many points on test 1 that I have for the other test? Because by now you know how to use scientific notation. I'm not going to ask you questions. Write this in scientific notation. You also know how to use significant figures. So I'm not going to ask you how many significant figures in this number like I did test 1, because you'll use it the rest of the test. Same thing with rounding off and the operational rules. Let me just remind you, when you have multiplication division, you have the same number, the number of significant figures in your answer should have the same number of significant figures as the numbers that has the lowest significant figure you're multiplying or dividing. When you're doing addition, that's different. You have the same number of significant figures past the decimal point as the number that has the fewest significant figures past the decimal point. One thing I passed up earlier, but I just realized, and I did it later on too, chemical symbols. I only asked you to learn 37, and you should know if I put down what's the chemical symbol for carbon, you should know it's C. But if I put down, ooh, the following, I need a pen. What element has this chemical symbol? And the answer is argon, one of my favorite noble gases, because I used it a lot in grad school. I'm not going to ask questions on scientific or significant figures, as I said. Talked about exact numbers, you learned about that. Periodic table, you should know what an example for an alkali metal. I asked that on test 1. Or if I ask you for an example of a halogen or a noble gas, first column of a periodic table are the alkali metals. You'll be given a periodic table like you've seen all semester on your test. Alkaline earth metals are the second column. Go to the right, the second to last column are the halogens, and then the noble gases are the last column. And if you know, and also what's a metal, like gold, silver, things like that, copper. But you should know, if I ask on a test, which I did on test 1, give an example of both the chemical symbol and the name of, say, a halogen, and my favorite one is chlorine, Cl, because I've used it a lot. Next, I start talking about atoms, and atoms are the smallest particle of an element. I don't have anything on Dalton's theory on, oh, I'm giving it away, but I'm going to help you out a little. That's why you should show up Wednesday when Friday. My week is totally off because I gave a test on Monday, and normally that's a Wednesday, so I'm thinking this is a Friday and coming up next. Hold on, I got to reboot. Now I'm calibrated. All right, what you should know when we talk about atoms are the subatomic particles. Those are the particles that make up an atom. Good news, I'm not going to make you do class participation like I did in the past. I'll just do it alone. You can do it mentally. And what are the three subatomic particles? Electron, negative charge. Proton, positive charge. Neutron, no charge. You should know where are the protons and neutrons in the nucleus. And then, slow down because I'm going at warp drive now. Go sublight for those of you who know science fiction. Okay. Again, the nucleus only contains protons and neutrons. Important thing, atomic number, you should know. The atomic number equals the number of protons and the number of electrons in an atom. And we went through this, and it was on test number 1. And where are the electrons? They're in the cells, the shells and subcells. Yeah, hold on. I got to reboot my job. The shells and subshells. Sally shell, never mind, I'm not going to say that one. But anyways, the electron shells, there's 1, 2, 3, and 4. And the number of subshells in 1 has 1, 2 has 2, 3 has 3, 4 has 4. Subshells are S. Hold on, I'll slow down. Remember, all this is on black. Does everybody here have internet access? Everybody here have access to Blackboard? You should. And the subshells, the only two you have to know from my class are S and P. S has 2 electrons, P has 6. And we put that all together in the electron configuration. I'll have more to say about electron configuration on Friday, so you should show up. And that's where you show where the electrons are. All right, this you should know. Valence electrons. What are they? They are the outermost electrons of an element. How do you find them? Look at the top of a periodic table, and you'll see a number there, Roman, and if you know the one I gave, also had numeric numbers, and that tells you how many valence electrons. The most you can have is 8. And those are the outermost, and those are the electrons involved in chemical bonds. And that was test number 1. All right, of all the tests, most students had trouble with this one. I'd highly recommend you go back and look at test number 2. You all should have it. If you need any answers, see me Friday before or after lab, and I'll be available. I'm going to stick around. I'm not going to run away on Friday, so this way you'll have plenty of time to ask questions. Plus, during the actual lab part, which is we're not going to have a lab, but we'll have more review, I'll videotape it and post it by Saturday. It should be about 3 hours. It'll take me a while to get that done, maybe Sunday, and I'll give you time to go back and look at it. All right, first of all, you should know what a Lewis structure is and how to do it. And how do you do a Lewis structure? Lewis structure shows you where, how many valence electrons an element has. How do you do that? For carbon, it has 4 valence electrons, and you write the symbol and a dot for each valence electron. Chlorine, 7 valence electrons. How do you show the Lewis structure? You do 1 on each side before you double up, and then you start doubling up. And 3 sides would have 2 dots, and 1 side would have 1. Doesn't matter which is which, the one side with the 1. Now, when we talk about Lewis structures, it helps us understand chemical bonds. And there are 2 types of chemical bonds. You should know. Ionic. Ionic is a chemical bond where you have a transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. Covalent bond, that's the sharing of pairs, pairs is 2, of one or more pairs of electrons between two atoms. So there's ionic and covalent. And they're all guided by or ruled by the octet rule. Atoms want to gain, lose, or atoms of elements want to gain, lose, or share electrons, so they have 8 valence electrons, the same number as the nearest noble gas. And here we have what's called forming ions, and they're positive ions and negative ions. And the way you figure it out, let's do one. Go look at test 2. You can see I have questions like that. If you look at test 2, I had a question, I forgot which elements I put down, but I asked you what ions do the following elements form? And how do you do that? Well, you look at, first of all, you have to know you have magnesium is Mg. And you have to know that the atomic number tells you how many electrons and protons it has. Atomic number, how many electrons and protons. Next, it wants to have the same number of electrons, i.e., that is the atomic number, as the nearest noble gas. And that's based on atomic number difference. Here, I'm at 12, neon is 10 away, or at 10, argon is 18, which is closer numerically, 2 or 8, hopefully I'll pick 2. Therefore, it wants to have the same number of electrons as neon, because that will give it an octet. And therefore, it really wants to go to 10 electrons, 12 protons. Each electron is a -1 charge. Each proton is a +1 charge. Do the math. Add this together. Keep an eye on me, I already made one mistake this morning. And you get +2. How do you show what ion is formed? You show the chemical symbol and then superscript to the right the number. If it's a 1, you just show plus or minus. If it's greater than 1, in this case +2, that would be that. And you know something? I should share this morning. Why don't you figure out what ion does oxygen form? I even gave you the chemical symbol. Everybody see it now better? Hold on. Quick announcement, if you plan on taking, and there are a couple students here, you know who I'm talking about, the final in the testing center, could you please see me before you leave today? Oh, I almost forgot. I put out an announcement. I also put it on Blackboard. An announcement, sent out an email that, or was in the test announcement, that because of Thanksgiving, the way it threw things off, I am extending the deadline for the extra credit project to Friday. If you haven't done it, there's still time to do it. And if you haven't, I would suggest you do it because you can get 10 bonus points, which always helps your grade. All right, let's do this. Question is, what ion will oxygen form? Oxygen, atomic number 8. Therefore, it has 8 electrons, 8 protons. What's the nearest noble gas? Well, you have 3 choices. Neon at 10, helium at 2, or argon at 18. And you notice it's at 8, to go to 10 is only 2 away, and that's the closest. Therefore, it wants to have the same number of electrons as neon. The protons don't change. Each electron is a -1. Each proton is a +1. And you do the math, now you add this together, and you'll get a -2. And therefore, how do you show that? I like the old style way. You can also do it this way. Either one works for me. Did I tell you I'm this close to the person who grades the final? Now, an important thing you should know, all molecules have a net zero charge. Therefore, when you have ions coming together, you'll have the number that gives it to a zero net charge. You can't change the charge, but you can change how many ions of each you have. If we look at the following question, which was on test number 2, write the molecular formula, or the simplest molecular formula, for a molecule with calcium +2, chloride -1. How do you do this? This is a +2 charge. This is a -1. It has to add to 0. You can't change these numbers, but you can change how many. This is a +2. You want this to be a -2. How do I do that? I have 2 of those. How do I show the molecule? The molecule has 1 calcium and 2 chlorine, and that's how you answer it. And why don't you try this one for your fun and enjoyment on this sunny winter almost day. Look at next week, luckily Wednesday, no snow or rain or ice. Don't forget, all lectures are on YouTube except the first couple I realized I never did, which I'm trying to work on this weekend. but you can always go back and look at those. All right, let's do this. How do we do this? We look at this and say, all molecules have a net zero charge. So this is a +1. This is a -2. It has to equal 0. Does it? No. How do I get this to equal 0? Well, this has to be a +2. I can't change the charge, but I can change how many. How do you do that? Well, how do you show that? 2 sodium, 1 oxygen, sodium oxide. When we talk about covalent bonds, there are 3 types you should know. And again, you can do it mentally, well, I'll do it out loud and help you out. I'll do class mental participation. Everybody think of what's the first type of covalent bond. Oh yeah, I got that real strong. Oh, that was hokey. But anyway, single bond. You should know. Single bond. How many pairs of electrons? 1 pair. Double bond. 2 pairs. Untitled. Triple bond. Well, chicken soup and vodka work. Just don't mix them together. Ugh. Anyway, triple bond. 3 pairs of electrons. I'm going to open up a new place. Soup and booze. Coming to your local neighborhood. Come in for a shot of chicken soup and vodka. Never mind. All right, but seriously, you should know. Single bond, 1 pair of electrons. Double bond, 2 pairs. Triple bond, 3 pairs. Nobody steal my idea, please. You should know how to draw the Lewis structures. If I ask you to draw the Lewis structure for the following molecule, and that would be nitrogen gas. How do you draw the Lewis structure? First of all, you find out how many valence electrons does nitrogen have, or any atom you're doing. It has 5 valence electrons. You have 2 of them. There's the Lewis structure. In a covalent molecule, you're going to have sharing of pairs of electrons. And you notice this has 3, oops, I just put a dot where I didn't want to put a dot. This has 3 unpaired, this has 3 unpaired. One nitrogen says to the other, you know atoms can talk, they can't. But anyway, I've got 3 unpaired electrons, you've got 3 unpaired, let's share. And they do. And that would be the Lewis structure for nitrogen gas. How do you know it's right? Each element has an octet. The only element that doesn't have an octet, or its octet is 2, is hydrogen. Notice 8 electrons around that nitrogen. 8 electrons there. And the next question is, what kind of bond is between the 2 nitrogens? And I'll let you look at the screen today. 3 pairs, it's a triple bond. Why don't you try drawing the Lewis structure for water? I will tell you this, oxygen's in the center. Again, if you're going to be taking the final in the testing center, see me today before you leave class, at the end of class. That's 3 of you. All right, looks like everybody's done. Let's take a look at this. Oxygen's in the center. Has, oh, I made a mistake. I'm sorry. Somebody should have caught me. It has 6 valence. I'm going home. Good night. But anyways, it has 6 valence electrons. I should have pulled out a periodic table. And hydrogen has 1. You can write it that way, or you can write it this way. And that's how you do it. Now, along the line here, I talked about polyatomic structures, or ions. And those are ions that share electrons in a covalent bond, and they also have ionic bond. And if I were to ask you to draw the I gave it away, but draw the structure, the Lewis structure for sodium hydroxide. Whenever you see a alkali metal, it's always going to be an ion. And sodium forms a +1 ion. Now, oxygen and hydrogen. Oxygen has 6 valence electrons. I got it right. And hydrogen has 1. So you have that, but you look here and say, uh-oh, something's wrong. Oxygen doesn't have 8 valence electrons. But where did the electron go from sodium? It went over to here. And that's the Lewis structure for sodium hydroxide. Along that way, give the formula for the molecule containing sodium plus, sulfate -2, and this would be a +1. This is a -2. It adds to 0, and then when you do this, how do you show that? You put Na2, and then one of those, sulfate, that's how you would do that. And why don't you try one for yourself? That would be with polyatomic ions. What would be the formula, molecular formula, for a molecule that has calcium +2 hydroxide -1? All right, everybody's done. This is a +2. This is a -1. It should add up to 0. It doesn't, so I need 2 of those. How do I show that? You use a bracket, closed bracket, to show for a polyatomic ion, and subscript to the right 2, and that's how you do that. All right, next I talked about chemical reactions. Now we start getting into good stuff. And here we have a chemical reaction. A plus B makes C. You should know A and B are the reactants. Also, sometimes I'll say on the class starting materials, C is the product. You should know how to balance a chemical equation. There are at least two on the final. I'll tell you that, so you know you should know how to do that. And remember my advice. When you're balancing a chemical equation, leave hydrogen and oxygen last. When you're balancing a chemical equation, leave hydrogen and oxygen last. And let me give you one to try, and then I'll do it. And here's an unbalanced chemical equation. And let me tell you, on the test and the final, I will never, ever put one down that's already balanced. If I ask you to balance it, you have to balance it. By the way, C3H8 is propane, and that's what you use in your barbecue. Hydrogen, oxygen, last. Oh, I put down drawing formula for water. No, just kidding. It's saying only one more day you have to put up with my bad jokes. So I usually don't joke during the final. All right, let's do it. If we look here, I'm going to follow my own advice because it's good advice. Do carbon first because the rest is hydrogen, oxygen. I have 3 carbons here. I can't change the formula, but I can change what's called the coefficient. I'll put 3 in front there. Therefore, I have 3 carbons. Next, I have 8 hydrogens. And here, how do I get 8 hydrogens on this side? I only have 2. Well, 2 goes into 8 4 times. So now I have 8 hydrogens. And last but not least, on this side I have 2 oxygens. How many on this side? I have 3 times 2, 6 oxygen, plus 4 times 1, 4 oxygen. That equals 10 oxygen. How do I get 10 on this side? 2 into 10 would be 5, and that's how you balance a chemical equation. Remember, leave hydrogen, oxygen last. It's helped me out for a long time, and it always helps and works. And notice I even have it in there. All right, next thing we got into good stuff, the mole. Remember, a mole is not a furry little creature in chemistry that digs holes in the ground. It's the chemist counting unit. And a mole is equal to different things. These will all be given to you in important information. You should know 1 mole of an element equals Avogadro's number, which is 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals Avogadro's number. Oh, the 2 fell off there. 6.02 times 10 to the 23rd. Oh, I'm embarrassed. Anyways, and, ooh, private announcement from Dr. White. Remember, my birthday is coming up the end of this month, and it's still not too late to get my favorite gift. All I want is a mole of pennies. 6.02 times 10 to the 23rd. If you figure that out, which I did once, it's 100 million piles, and each pile has 1 billion pennies. So it's 100 million times $1 billion, 100 million billion dollars. It's just a mole of pennies. There's still time to save, not really. All right, next, you should know 1 mole of an element equals the atomic weight of the element in grams for this class, and 1 mole of a compound equals the molecular weight of a compound. As per each test, please use atomic weights to 3 significant figures, and that makes your life easier, hopefully. And remember, the molecular weight of a compound is the sum of all atomic weights for that compound. At this point, I introduced you to, I haven't said it in a while, your good buddy, your good friend, unit analysis. And why don't you try this one out first, and I'll do it. How many molecules, oxygen, are in 5.71 moles of oxygen? Here's your good buddy. If I can hear it, all of you can hear it. Oh, that's that. Thank you. All right, anybody need more time? Let's do this. First of all, what are we being asked to find? What are we given? And And this is the only number we have to start with, so I'm going to start with it. What am I trying, if I had some ratio and I could convert it into the final answer, what units do I want my final answer in? Molecules, O2, and now you use your good buddy, your good friend, hopefully it has been this semester, unit analysis. Whatever you're trying to get to goes on top. Whatever units you're trying to get rid of goes underneath on the ratio. Where do you get those numbers? 1 mole of a compound equals Avogadro's number. Therefore, for every 1 mole, I have 6.02 times 10 to the 23rd. Before I pick up my calculator, moles of O2 divided by moles, anything divided by itself equals 1. Units cancel out. I'm left with the right units. I go over to my calculator now. I put in the numbers. My calculator gives me this one. Remember, on the final, it will say, I'll remind you, please use proper significant figures for all calculated answers. My three significant root again, 3. How do you round that off to 3? Keep the 3, keep the 4, keep the 3. This is a number to round off. It's 5 or higher. This gets dropped. That becomes a 4. And that would be your answer. And why don't you try this one? How many grams water are 8.211 moles of water? Remember, on Friday, I'll continue the review. You don't need to bring your safety goggles, but you do need to wear proper shoes. No flip-flops, no open back shoes, no house slippers or anything like that. All right, with the time where it is, and since I can't stop the clock, hold on, no, I couldn't. Let me go ahead and do this. All right, what are we trying to find? Grams of water. What are we given? This. If I can do this in one conversion. Here's what I start with. What am I trying to get to? Grams of water. Use my good buddy, I gotta slip it in one more time at least. My good friend, unit analysis, whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Where do I get this number? 1 mole of a compound equals the molecular weight. Ooh, there's no molecular weight. You have to figure it out. The molecular weight is the sum of all atomic weights. For water, I have 2 hydrogen, 1 oxygen. Two times the atomic weight of hydrogen, 1 times the atomic weight of oxygen. When you add, you get the same number of significant figures in your answer as the number that has the fewest significant figures past the decimal. This is 1, 2, so my answer should have 1. Therefore, 1 mole, 18.0 grams. Come over to my calculator. And here, if I round it off, notice 4, 3, the answer should be 3. It's either 1.48 times 10 squared or 148 grams. And with that, I'm going to let you out a whole, I'll go slow, 55 seconds early. Now, don't forget, come to lab, it'll be worthwhile. Those of you who are taking the test in the testing center,